Welcome to Maths Unlocked. My mission is to make complex math simple and visual for everyone. Creating these detailed, animated videos takes a lot of time and effort. Your support through a simple like, share, or subscription helps this content reach more students who might need it. Please take a moment to subscribe. Thank you for your incredible support. Hello students, and welcome to our one-shot lecture on limits and continuity for CBSE Class 11. Let's begin. What exactly is a limit? Intuitively, a limit is the value. A function, fx, approaches as its input, x, gets closer and closer to some value, c. We write this as the limit of fx. As x approaches, c equals L. The key idea is that we are interested in the behavior of the function near a point, not necessarily at the point itself. Let's look at an intuitive example. Consider the function fx equals x squared minus 4, all divided by x minus 2. If we try to evaluate this function at x equals 2, we get 0 divided by 0, which is an undefined form. However, we can see what value the function approaches. As we look at the graph, you can see there's a hole at x equals 2, but the function's value gets very close to 4 from both sides. We can also see this in a table of values. As x gets closer to 2, the function's value gets closer to 4. Therefore, we say the limit of this function as x approaches 2 is 4. This brings us to the formal concept of one-sided limits. The left-hand limit, or LHL, is the value the function approaches as x comes from the left side, or the negative side. The right-hand limit, or RHL, is the value it approaches from the right side, or the positive side. For a limit to exist at a point, a crucial condition must be met. The left-hand limit must equal the right-hand limit. Limits follow some very useful algebraic rules that simplify calculations. For two functions, fx and gx, the limit of their sum is the sum of their individual limits. This also applies to their difference, product, and quotient, with the important condition that you cannot divide by a limit that is 0. We can also pull a constant multiple out of a limit. Let's see how this works with a quick example. To find the limit of 3x squared plus 2x minus 1 as x approaches 1, we can simply substitute the value in, giving us an answer of 4. Now, let's discuss continuity. A function is said to be continuous if you can draw its graph without lifting your pen from the paper, meaning there are no breaks, jumps, or holes. For a function fixed to be continuous at a point x equals c, 3 mathematical conditions must be satisfied. The function must be defined at c. The limit of the function as x approaches c must exist. And finally, the value of the limit must be equal to the function's value at c. Let's look at two final examples. First, consider the function px equals 2x plus 3 at x equals 1. The function's value at 1 is 5, and its limit as x approaches 1 is also 5. Since these are equal, the function is continuous. Now, consider a piecewise function where fx is 1 for x less than or equal to 0, and 2 for x greater than 0. At x equals 0, the left-hand limit is 1, but the right-hand limit is 2. Since the LHL does not equal the RHL, the limit does not exist, and therefore the function is not continuous at x equals 0. This is known as a jump discontinuity.